at our review quiz? See how we're doing? Okay, so shade in the region. A naught intersection with B. Okay, so A naught, basically, if we circled A naught would be everything outside of A, but then it has to intersect with B. Okay, so this is this guy right here. Okay, so that's everything outside of A intersected with B. Okay, how many even 5-digit numbers are there if repetition is allowed? So they even gave you a hint. Okay, it can't start with 0 because otherwise it wouldn't be a 5-digit number. Okay, so it can't be 0. It can be everything else, and it says even. So we've got 0, 2, 4, 6, and 8. So there's 5 options there. There's 9 options there. Repetition is allowed. 10, 10, 10. Okay, so it should be 45,000. Okay, this next one. Okay, guys. Hopefully you all got this next one. Okay, because it's a common denominator. You just add up the top. 5 and 4 is 9 over y, and y cannot equal 0. That was it. 5 and 4? Pretty sure it's 9.
Oh my God. Yeah. Well, use your head, man.
All right. Okay, so I heard some rumblings about, oh, like, do we cancel out the denominator? Okay, we only ever do that when it's an equation. If there's something equals, then we thank the denominator for doing its job, and we look at the numerator. But in this case, okay, it's just an expression. There's no equal sign, so there's no canceling out the denominator. Okay, the next one, a metal rod. Okay, and it tells us we're looking at a linear regression. So guys, yes, I expect that you can take a quick moment, put the data in, right? Don't forget how to do all this. We're doing calc, okay, linear regression. Calculate, okay, and it gives us this lovely thing, and then it wants in the slope. So this one, yeah, you had to remember what slope was. The slope is the A value, so 0.36. Okay. And then this last guy, couple different ways to solve it. Okay, some of you were using your logarithms. Some of you were looking at it and saying, oh, I can do a common base. Okay. Some of you just like were really good at guessing and checking, and it just kind of made sense. Okay, so like we'll do a couple ways. So one of the ways is to do common bases. So if you did this, if you transformed 729 and you said, oh, that's the same as 9 to the power 3, okay, when you have your common bases, right, you can say x plus 1 is equal to 3, so x is equal to 2. Okay. If you wanted to, okay, you could have also done, okay, the base becomes the base of the log. So you could have gone log base 9, okay, of 729 is equal to x plus 1. Okay, you could have done that. Okay, and then this would have gotten you just evaluate it, it would have been 3. Okay, minus 1, minus 1. Okay, so either way would have been fine. Okay, so common bases, or you could have done the log, right, where we brought it over there. Right. So let's go ahead and get ready for today's lesson. All right. No. You want me to collect them? Oh. Okay, so how did we do though? Like we're remembering this, or like, thank goodness it's just a review. We're doing okay? All right, I will let you. All right, guys, go ahead and open up your notes package. Okay, we're going to talk about finance today. We're making money. All right. All right, let's take a look. Okay, finance is always a good thing to understand, okay, and to be knowledgeable about, because you want to be able to make some good investments. You want to make sure that you're putting your money into things that are going to give you interest on your interest. Does that need to go on my desk?
No.
It's going to be a problem.
No.
Okay, like zip it up in your bag then.
You just checking his nails.
Yeah. Weird. All right, let's make sure we have some definitions down pat. Okay, and then we're going to introduce a new formula that we're using for finance. Okay, and then I'll kind of walk you through the steps on how to solve these types of problems. So we'll have a couple different things that we can figure out. So the first thing you want to know is, hey, compound interest. Okay, that's making interest on your interest. So that would be a good thing to have. Okay, so interest earned on both the original amount that was invested and any interest that has accumulated. Yeah. All right. So, guys, when we're talking about banking interest rates, you're going to notice that they're going to give it to you in a percent. How do I move from a percent to a decimal? Yes.
Or you can move the decimal 2 places.
Yes, move the decimal 2 places to the left or divide by 100. Okay, so just make sure that you remember how to go from a percent to a decimal. So for example, guys, 78% is the same as 0.78. Okay? 2%. Okay, make sure that you move the decimal place over twice, because if you give me just 0.2, you've given me 20%, not 2%. So it's 0.02. Right? You got to move, if you're doing the move the decimal place over, it's got to go 1, 2, and you got to fill it in with the 0. Okay? What happens if it was 1.4%? What is that as a decimal? 0.014. Yeah. Okay. So let's just double check that we can convert from a percent to a decimal. So here's an example. You have $10,000 in your bank account and you're making 4% interest rate per year. After the first year, you would have $10,400. So you've just made $400 in interest. Okay, but 10 years later, that $10,000 would have grown to over $14,000 because you're making interest on the $10,000 plus the interest on the interest, and so your amount kind of keeps growing, and that's where good investments, if you keep them in long enough, will give you good results. Okay, so we're going to be using this formula. So let's break it apart, make sure that we understand what all the bits are and how we can use the formula. Okay, so F stands for the final amount. Okay, so if we want to know how much our investment is worth after so many years, that's what F stands for. I is going to be, so this is our I, the capital I. I is your initial amount. How much did we start with? Okay. The little I is your annual interest rate. Okay. The guys, always as a decimal. Okay. The question will always give it to you as a percent, and you always need to make it into a decimal. Okay, so convert to a decimal, just divide by 100. Okay. Then you have an N, and the N appears twice in the formula. Okay, the first time it appears under the I, and then it appears as an exponent. And N is the number of compounding periods. Okay, and then T is going to be your time in years. So a few other things to know. So like we need to know this and be able to use this. Another thing that we need to know is our common definitions. If you see annual or per annum, that means yearly. Okay, once a year. If you see semi-annual, that means twice a year. Oh, it says right there. I don't have to write it in. Okay, once per year, twice per year. There we go. Quarterly is 4 times a year, right? You have quarters. So like right now, we're in the 4th quarter of this year. We're in December, and then January comes, and we're in the 1st quarter of 2026. Okay, monthly, there's 12 months in the year, so that happens 12 times a year if you're, say your compounding period is monthly. And then daily, okay, here's your conversion rate. There are 365 days in the year. We will not worry about leap years. Okay, 365 days. All right, so here's how it works. Okay, example number 1. Andrew invested $100 in a savings account that pays 4% per annum. Okay, so that's just once a year. Okay, compounded semi-annually. Okay, that's twice per year for 3 years. Determine the value of his investment at the end of the term. So here's how I would like for you to do it. I want us to write out everything that we know and that we need. Okay, so the first thing you're going to do is you're going to write your formula over here. Yeah. Okay, so let's start at the top. We're trying to find out F. Okay, this is my I. Let me just clean that up a little bit. There we go. Okay, the initial amount is $100. Okay, my interest rate, okay, that's 4%. Okay, so we want it as a decimal. Okay, N is what? No.
Pretty sure semi-annually, twice a year for 3 years.
Okay, so semi-annually, so it's the compounding period, so N is 2, and T is 3. Okay, so once you write down everything that you know and what you're trying to figure out, then you can plug it into the formula. Okay, so we're going to say F is our unknown, so we have 100, and we're going to go 1 plus 0.04 divided by 2 to the exponent. Okay, we're going to do 2 times 3 is our exponent. Okay, so I'm just writing all the substitutions in. When you're putting it in, you can like do that little mental math. You can do to the exponent 6. Okay, so let's clean that up just a little bit. Okay, so we have 100, 1 plus, if we do this, okay, with our calculator, so we've got 1 plus 0.04 divided by 2, okay, 1.02. All right, so 1.02 to to the exponent 6. Okay, this is a little bit nicer. So if you like break it up a little bit just to clean it up, then when you put it into your calculator, we won't have any issues with fractions or weird exponents or anything like that. So this we're just going to evaluate. You're just going to, okay, you're going to put that into your calculator. So 100 times 1.02 to the exponent 6. Okay, just like that. Okay, now don't forget we're dealing with money. Okay, so with money, I would like to see 2 decimal places, okay, and proper rounding. So guys, when I'm looking here, I want 2 decimal places. I need to have, okay, I'm sitting at this, I'm looking at the 1, and I'm like, do I keep it a 1, or do I round up, or do I keep the same? Yeah, so you look next door, if it's 5 or higher, you're going to round up. So it'll be $112.62. Okay. And then, okay. And then a nice sentence at the end of the term. Andrew's investment is worth okay, so please don't forget 2 decimal places and a $ in your sentence answer. Yeah, it's not a great investment, that one.
Are we actually gonna have like our guys getting capital, or are they just gonna take like $12?
It's pretty minimal. Yeah. Okay. Okay, so the next one, we're doing the same thing. We start with our formula. So our final amount is equal to our initial amount times 1 plus I over n to the exponent nt. Okay, guys, let's get some, write it out every single time. Okay, and then on the side, I want you to write what you know. Okay, determine the value of the investment. So again, what we're trying to find is our F value. The initial investment is 7,000. Okay, and it says that it's a 6-year term, so the time is 6 years. Okay, it's compounded quarterly, so that's your N, that's your compounding period. Okay, so N is 4 because it's quarterly. Okay, and I, that's my I. My interest rate, it says 5%. So we write it as a decimal, so divide it by 100. Okay, and how much does he have at the end of the 6 years? So let's plug it in. So we have $7,000, 1 plus 0.05 divided by 4. 4, okay, times 6. Okay, 0.05 divided by 4, okay, 1.0125. All right, so the final amount, okay, you're like writing some of this stuff down.
Is that a 4 or a 9? And
Yes. Okay, if you got 9,431 and 46 cents, then you are on the right track. All right. Okay, so you've seen how it works to find the final amount. Okay, that's like your most basic, right? Plug your numbers into your formula and just have your calculator calculate it for you. Okay, but what happens if, okay, they change it up a little bit and they know how much you made at the end? Okay, they could ask you what is your initial amount that you invested. They could ask you what is, maybe you know the initial amount, but they say what is the interest rate that it was invested for. Or they could even ask how many years did your initial amount stay in the investment in order to come out with this amount. Okay, so you can see how we can ask different questions and how we have to change the formula around and use what we've learned about exponents and logarithms depending on where the unknown is. Okay, was it difficult to solve for f? No, it was like substitution and then just calculate. Okay, when the unknown is inside the formula, okay, on the other side, okay, we're going to have to use some of our exponential logarithmic skills. All right, so here we go. Example number 3. So we'll invest $1,000 for 10 years. If he earns an annual interest rate of 7.75 compounded monthly, determine the total interest that he earned over the 10 years. Okay, so guys, this one is a little bit different because here's what we need to understand right here. Okay, the total interest is equal to the final amount subtract the initial amount. Right? Our formula does not tell us how much interest we earn because it's like compounded in there. It's part of the final amount. Okay, so if we actually wanted to pull out how much interest was earned, we're going to put everything into the formula like we have been doing. Okay, solve for it. We're going to find out our final amount. We're going to subtract off the initial amount, which is $1,000, and then that will tell us how much interest we made over the 10 years. Okay. All right, our interest rate is 7.75. Okay, it says that we have compounded monthly. So our number is 12 because our compounding period is monthly. And it tells us 10 years. So our time is 10 years. Okay, so $1,000. Okay, this time I'm gonna just let the calculator do all of it and not break it into little bits because there's gonna be quite a big decimal there. Okay, so if you find that your answer is a little bit different than your neighbor's, it's probably just due to rounding. Okay, so if we keep all the numbers in here, head over to the calculator. Okay, so we have 1,000 times 1 plus 0.0775 divided by 12. Okay, end bracket to the exponent 12 times 10, which is 120. Okay, so it looks like I got 2,165.19. No,
Yes. He invested.
No.
1,000.
yeah, but not, he didn't keep putting money in. He just did $1,000 and he left it for 10 years. Yeah. So, okay, the total interest. Okay, I know it's a little underwhelming that these investments don't yield massive returns. Okay, so over 10 years, he doubled his money. Okay, but it took 10 years to do it. So that's another thing that we just need to recognize and realize is that doing a lot of these kinds of investments, it takes a lot of time. This is not a make rich quick kind of finance. Okay, so you took the total amount that he earned, subtract off the initial $1,000 in order to get what the interest was. Okay, so we needed to know this in order to do the question. Okay, so example 4 is we're getting to the ones that now ask us like when we would expect our money to double. Okay, so you invest $500 in an account paying 6% compounded semi-annually. Determine the value of the investment after 5 years. So we're trying to figure out the final amount. The initial amount is 500. Okay, the interest rate is 6%, which is 0.06. The compounding period is semi-annually, so it's 2. Okay. The time is 5 years, and we want to determine the value. So here we go. So we have 500, 1 plus 0.06 divided by 2. 2 times 5. Okay, we can put that into our calculator. We should get 671.96. Okay, so let's do that. So we had 500, 1 plus 0.06 divided by 2 to the exponent 10. There you go, 671.96. Okay, so we saw that it took 5 years for our money to only go up to 671. Okay, how long do you think it would take for it to double? That's what we get to figure out. Okay, so this is what we want to know. Okay, well, first of all, what's double? What are we doubling? Yeah, we're doubling our initial amount, guys. We're doubling the 500. So our final amount is going to be 1,000, right? This is double the 500. Okay, so you have to be able to take a look at your word problem and translate it. Okay, the initial amount is still the 500. The interest rate is still 6%. Okay, the compounding period is still semi-annually, and this time we don't know the time. All right, so we have $1,000. We started with 500. I'm putting it into the formula. Now I'm going to solve for t. Okay, so guys, remember, when we have our unknown in the exponent, okay, we want to, don't forget how we solved for exponents before. Okay, so if we do, okay, I'm just going to rewrite this a bit. Okay, clean this up in the middle. Guys, do you see that this is my base? Okay, so I'm going to divide both sides by 500. Okay, I'm going to write it up here. So I'm left with, okay guys, could I do same bases and solve it that way? Can I get same bases with this? I've got like a decimal and I've got number 2. Okay, can't do same bases. So how did we solve for our exponent? Yeah, we're gonna, when we don't have the same bases, we're gonna use our log rules. Okay, so the base of the exponent becomes the base of my log. You guys remember this? I'm gonna do it in a different color so you kind of really see. Okay, the base of my exponent becomes the base of my log. So we're going to go log 1.03 of 2 is equal to 2t. Okay, we're going to put this into the calculator. We're going to divide it by 2 to get to our t. Okay, so log base 103 of argument 2. Okay, so log 1.03, okay, of my argument 2 is equal to that, and we divide by 2. Okay, 11.7.
Why don't we make like some standard investment?
Okay, one final thing. Okay, we're going to round up to the nearest year, because in order to double it, would we be doubled at 11? No, we wouldn't. Okay, because it would be 11.7, so we have to be more. So for this one, we're going to round up to the nearest year. Okay. So our answer is, for him to double his investment, it's going to take 12 years. Yeah. For 500 bucks to make it to 1,000. Exactly. All right. The other type of question that we're looking at, put it on my desk. Okay, the other type of question that we're going to look at is here in example 5. Okay. Determine the interest rate. Okay, to one decimal place at which a $3,000 investment compounded quarterly will double in value over a period of 5 years. Shh, guys, not sure why there's so much chatter. As far as I know, this is pretty new. Okay, so start by writing down everything that you know. Okay, do you have your F? Do you have your initial amount? Do you have an interest rate? Do you have a compounding period? Do you have how many years? Okay, what do you have? So this is what we're trying to figure out. Okay, our initial investment is $3,000. Compounded quarterly, so N is 4. Doubles in value, so the final amount is double our initial amount, so our final amount is 6,000. Okay, and the time period is 5 years. we have n. There we go, 4 times 5. Okay, so this time our unknown is inside the brackets. Okay, so in this case, I'm still going to divide both sides by 3,000. Okay, so now we have our unknown is raised to some exponent. Okay, so this is the one where we want our unknown to have the exponent of 1. Okay, so how do we get rid of this to the exponent of 20? How do we like undo an exponent of 20? You're like close in thinking that. Yeah, remember we do the reciprocal of the amount so that when we multiply our exponents, 20 divided by 20 gives us our 1. Okay, so in this case, we would need to, okay, both sides get the exponent of the reciprocal. Okay, so that way this side becomes 1. Okay, so now here's what we have. I'll just clean it up a little bit. We have 2 to the exponent 1 over 20 is equal to 1 plus I over 4. So now we can do, right, now we can subtract 1, like, okay. So we want the calculator to carry all the decimal places for us. Okay, so we're going to do this. We're going to go 2 to the exponent 1 divided by 20. Okay, we're good with that? Okay, so we've got our number. So we have this. Okay, now we're going to subtract 1. Subtract 1. Okay, so now we have this decimal. Okay, and then we're going to, guys, what do we need to do? So this is gone. What do we need to do to just get I by itself? Times by 4. Okay. Okay, so we have that, like this is what's in our calculator right now. We're just going to multiply it by 4 times 4. Okay, so that gives us an answer of 0.14. Okay, and it actually, it asks us to, oh, let me do a little bit more. 141, because. So the interest rate, because remember, this is in decimal form, and we want to give it the interest rate in percent. And it wants it to 1 decimal place in percent. So that means we have to have 3 decimal places in decimal form so that when we convert this to a percent, okay, we have 14.1%. Okay, let's take, we're not taking the whole amount of time, guys. Okay, let's take a little bit amount of time to do the 3 practice questions. I'm thinking we can do them up at the board. Okay, so that way I kind of see how things are going. So go ahead and send a group member over to grab a workbook, and we're going to be doing page 281. Okay, we're going to do 2, 3, and 11. All right. So what we're going to notice is some of the languaging is similar. Okay. So you'll notice that when we talk about exponential growth and decay, that it's a lot simpler than the finance, right? Because we're not having to compound, you know, on different things. So the formula you'll see is similar. So take a look at, okay, the formula for growth just doesn't have the compounding period because we're not talking about money. So there's no end value for this one. So before there was the interest rate was divided by n, and then the n showed up again in the exponent. So in this case, there's no n's, but the rest of it is the same. So what you're going to know is we're going to be using words like growth or appreciation. Okay, so for example, if you were to buy a piece of art, okay, art is supposed to appreciate over time, which means it's supposed to gain in value. Okay, so appreciation, so this is the increase. And you guys will notice that there's an addition sign in the formula. Okay, so when things grow, we're going to be adding to them. Depreciation is when things lose value. So for example, you buy a car. As soon as you drive your car off the parking lot, it depreciates in value. It goes down. It decreases. Okay. So be okay with some of the vocabulary. Appreciation, okay, it goes up. Depreciation, it decreases or goes down. And what you'll notice is, okay, for the depreciation, there's going to be a subtraction in the formula. Okay, the other things are very similar to finance. F is our final amount, I is our initial amount, capital I. Our interest rate is still little I, and then T is still the number of years. All right. So let's take a look at this. The initial price of a car is $30,000. The value of the car depreciates by 20% per year. If the car is new in 2005, how much will it be worth in 2010? Okay, so the way that the process that we do, we still write out everything we know. Okay, we're trying to figure out how much it's going to be worth. What's the final value? We know the initial value. The initial price of the car was $30,000. Okay, it says it depreciates by 20%. So the interest rate is 20%. Let's divide that by 100 to get our decimal, 0.2. And the number of years, okay, 2010 subtract 2005 gives us 5 years. Okay, then the big thing is, which formula do we use? The one with the plus or the one with the minus? It depreciates, so you're going to use the one with the minus. Okay, go ahead and sub the information in, 30,000. 1 minus 0.2 over 5 years. Okay, so the final amount, okay, this we can just put into our calculator. It's in the hall. You can close the door if you want. Okay, so that that beautiful $30,000 car in 5 years isn't even worth $10,000 anymore. Okay, that's the reality of cars. Okay. All right. Yes. Oh, sorry, it should be a T. You're right. Yeah. Yeah. I just had number in my mind, number of times, but you're right. Totally was a T. Okay, how long will it take to the nearest tenth of a year for this car to be worth half of its original value? Okay, so it wants to know if the initial amount is 30,000, when did it pass by half of its value, right? So 15,000. Okay, the interest rate is it's still depreciating at 20%. And this time we're trying to figure out how long did it take. So we know that it should be less than 5 years because in 5 years it's less than $10,000. We're trying to kind of pinpoint to the nearest tenth of a year when it like fell halfway. Okay. Okay, so we're doing 1 minus the interest for depreciation. So we know that the final amount was the 15,000. Okay, so when we have our unknown is in our exponent, guys, this would be a great time to use logarithms. So if we divide both sides by 30,000, okay, so we're at this point. So don't forget the base of the exponent becomes the base of our log. So if we do log 0.8 of the argument, that will equal our t value. So let's head over to the calculator and we'll do math log base. Okay, 0.8, 0.5. Okay, 3.1. Okay, so the car will be worth half of its value after 3.1 years.